Hello everyone, I'd like to welcome you to this video titled Real World Problems, Rates and Unit Rates, and I would like for you to get out your Math in Focus book and turn to page 247. Get out your math journal, pencil, and a calculator. So in this video, we're going to take a look at solving real world problems involving rates and unit rates. So we can see the problem here that a machine, and this is on page 248. I want you to fill this in with me as we're going through it together. A machine takes 10 minutes to seal 50 boxes. At this rate, how many boxes can the machine seal in an hour? So important to think through a couple things here. Okay, so we know 10 minutes, 50 boxes. We know that 1 hour is going to equal 60 minutes here. All right, and that we know in 10 minutes, 50 boxes. All right, so now we got to think about 60 minutes. We have 50 boxes times 6. Okay, where are we getting that from? We know that there are 10 minutes in an hour. Okay, so we take that 50, multiply it by 6, and that's going to give us 300. Okay, and then we can see that the machine can seal 300 boxes in an hour. Okay, so when we think about this, once again, even looking at the timeline over here, we have 10 minutes, multiply it times 6 gives us 60 minutes. So 10 minutes, 50 boxes, and therefore since we multiplied the 10 minutes by 6 to get to 60, we're going to multiply the 50 boxes by 6 again to get to 300 there. Okay, so we can see that in an hour, 300 boxes the machine can seal. So let's jump over to page 250. And we're going to take a look at the problem at the top of 250, practice solving two-part real-world problems involving rates and unit rates. So we have here that a machine can fill 16 identical bottles with ketchup in 2 minutes. At this rate, how many bottles can the machine fill per minute? Okay, so we think about a couple things with this problem here. In 2 minutes, 16 bottles. Okay, so that's the rate that we have, but that's not the unit rate. Remember, it has to be per minute. Okay, so in order to get it in 1 minute, what we do is we take that 2 minutes, divide it. We'll have to divide it by 2, but we think about the amount that could be made. So we take in 1 minute, 16 bottles divided by 2. It's going to be 8 bottles there. And so we know the machine can fill 8 bottles per minute there. Okay, and why do we divide it by 2? Because we got to get that 2 minutes down to a 1. Okay, or we can even think about what would be half of 16, since 1 is half of 2. Another way of doing that, in order to get the 8 bottles per minute. So understanding that the machine can fill 8 bottles per minute, okay, so we can figure out at this rate how many minutes will the machine take to fill 64 bottles. So we know 8 bottles in a minute is the unit rate. And then what we do here is we take the 1 bottle and divide by 8. So that looks at 1 minute, 8 bottles. And so we need to think about our 64 bottles equals, it's going to be translated to 1 bottle every 8 minutes. You're going to multiply that 64 times the 1/8. That's going to equal 8 minutes there. So we can see that the machine will take 8 minutes to fill 64 bottles. And when we think about why is it 1/8, because we know 1 bottle took 1/8 of a minute, okay, to create there. Okay, so we take 64 bottles and multiply it by the 1/8 is how long it takes to make 1 bottle, then you get 8 minutes to fill 64 bottles. Okay, let's jump over to page 251. says practice reading a table to find information to solve multi-step rate problems. So it says the table shows the charges for renting a bicycle. Tyler rented a bicycle from 10 a.m. to 2 p.m. on the same day. How much did Tyler pay for renting the bicycle? Okay, so we can see a couple things here from the table. First hour is $3. For every additional half hour is $2.50. Okay, so first of all, we need to think about the time elapsed from 10 a.m. to 2 p.m., and that's going to be 4 hours. And then we know the charge for the first hour we can see is $3. All right, and then the charge for each additional half an hour. So 2 times the cost for each additional half an hour, $2. We can see with that. So why do we have 2 of that? Because we know 2 half hours equals an hour, so it'll just tell us how much it is per hour. So 2 times $2.50 is going to give us $5 per hour there. Okay, based upon each additional half an hour. So figuring out how much it is for an hour is important for this, since we have 4 hours that we're dealing with. So we can figure out the charge for the last 3 hours. So again, remember, rented it for 4 hours, first charged $3 for an hour, and then $2.50 after that. So we take the $5, multiply it by 3, and that's going to give us $15 there. All right, now that's not the total, that's just how much for the last 3 hours. Now what we need to do is we need to take the amount from the first hour then, the $3, add it to the $15, which is the charge for the next 3 hours, and that's going to give us $18 there. Then we can see that Tyler paid $18 for renting the bicycle. Okay, so this is how you take a look at a table and use it to help you solve multi-step rate problems. Now we're going to jump over to page 253. We're going to look at practice solving multi-step real-world problems involving comparison of unit rates. So we can see that Haley scored 87 points in 5 basketball games and Bianca scored 45 points in 2 basketball games. Which of the 2 players scored more points per game? So we're going to take a look at this. So we can see, first of all, that in 5 games, Haley scored 87 points. Okay, in order to figure out how much she scored in 1 game, we take that 87 and we divide it by 5, and we can see that 17.4 points. You can put that in, 17 points per game there. Okay, so we take the total amount of points divided by the amount of games, and that's how much you get per game. So Bianca, 45 points. So in order to figure out 1 game, you take the 45 points, divide it by 2. That's going to give you 22.5 points per game that Bianca scored. So based upon this, figuring out how much per game, you can see since 22.5 is greater than 17.4, that Bianca, once you write this in, scored more points per game. So this is how you take a look at comparing 2 unit rates. And this concludes the video on real-world problems involving rates and unit rates. If you have any questions about this concept, please come and see me.